Question number 1. Figure number 1 shows a garden chair hanging from a spring. You can see here the chair is hanging with the spring. The weight of the person causes the spring to extend. You can see there a person is sitting in the chair. Due to its weight, we can see the extension in the spring. Why does the weight of the person causes the spring to extend? It is an AO2 question, and this question is from the topic of forces and elasticity. We can see here in the figure that the weight of the person is acting downward, and weight is a force, and the force is acting downward. Therefore, it will pull the spring downward. As a result, there is an extension in the spring. The correct option is the weight of the person acts in all direction. Weight acts upward, weight acts downwards. The correct answer is the weight of the person is acting downward. 1.2 is an AO1 question, and this question is from the topic of gravity. Complete the sentence. Choose the answer from the box. We have three different options: a gravitational, a frictional, and electrostatic. The weight of the person in the figure 1 is a gravitational force. So weight is a force due to the pull of the earth, which is acting on the body of the man, and it is acting downward. So the weight of the person in figure number 1 is a gravitational force. And we have the formula that weight is equal to mass of the person into gravitational pull of the earth. The weight of the person causes an extension in the spring of 0.070 meters. The spring constant of the spring is 12,000 Newton per meter. 1.3 is an AO2 question, and this question is again from the topic of forces and elasticity. Calculate the weight of the person. The equation is already given here. The weight is equal to spring constant into extension. We are given the spring constant value is 12,000 Newton per meter. The extension in the spring is 0.070 meter. We need to find the weight, means we need to find the force. We have been given the equation that weight is equal to spring constant into extension. We are going to use both of the values in our equation. So weight is equal to spring constant value is 12,000 times extension, which is 0.07. With the help of the calculator, the answer is 840 newtons. 1.4 is an AO2 question. Calculate the elastic potential energy stored in the extended spring. Use the equation. The elastic potential energy stored, that is equal to 0.5 into spring constant time the square of the extension happens in the spring. This question is again from the topic of forces and elasticity. We have the spring constant value, that is 12,000 Newton per meter, and we know that the extension in the spring, that is 0.070 meter, and we have this value in the part 1.3. We need to find the elastic potential energy. So we have the formula of the elastic potential energy, that is 0.5 times spring constant into square of the extension. So we will use all the values in the above equation. Therefore, the elastic potential energy is equal to 0.5 into spring constant, that is 12,000, into square of the extension, that is 0.07, and we need to use the calculator. The answer is 29.4 joules. 1.5 is an AO1 question, and this question is from the topic of forces and elasticity. If there is more than one person on the chair, the spring would become inelastically deformed. What is meant by inelastically deformed? So inelastically deformed means that when the spring will extend and it will not go back to its original shape after removing the force, that is called inelastically deformed. If the force is removed and the spring goes back to its original shape, then it is called elastically deformed. But the question is, what is meant by inelastically deformed? So we can see here there are three options. We will pick the option the spring will not go back to its original length when the force is removed. It means there is change in the length of the spring. As a result of that, the spring is not going back to its original length. So correct option is the spring will not go back to its original length when the force is removed. The manufacturer of the chair investigated the extension of a new spring. 1.6 is a practical based activity and it is an AO3 question. Figure number 2 shows slotted meshes hanging from the spring, which we can see here. The weight of the meshes extends the spring. We can see the actual spring is A, and on hanging the mesh, we can see there is change in the length and it has extended. I just gave an example. If original length is 5 cm and after hanging the mesh it changes from 5 cm to 7 cm, we can see here the change in length is 7 minus 5, that is 2 cm. Which length in figure 2 represents extension of the spring? Tick one box. If you see in figure number 2, this is the actual length. This is after the force is applied on the spring. From this position to this position is increase in length. So this is called extension of the spring. If we consider 7 cm is total length after applying the force, 5 cm is the actual length. So the change in length or the extension is 7 minus 5, that is 2 cm. So the extension is B. So the correct option is B. 1.7 is an AO1 question. Again, it is a practical based activity. And this question is from Forces and Elasticity. Which graph shows the extension of the spring is directly proportional to the force applied to the spring? Directly proportional means a straight line which is passing through the origin. We have four options. We can see here in first option we can see the force and the extension. The straight line is present, but the straight line is not passing through the origin. In option number C, we can see here the line is passing through the origin, but it is not a straight line. In option number D, we can see here a straight line is present, but it is not passing through the origin. Among A, B, C and D, the straight line which is passing through the origin, that is option number B. (1.8) is an AO3 question, and this question is from the required practical activity number 18. Table number 1 shows the result of manufacturer's investigation. Force in newtons is given 100 newton and 200 newton, and extension which happens in the spring is 0.08 meter and 0.016 meters. Suggest two improvements to the investigation. If we look here in our question, we can see here clearly that when the force is applied, there is an extension in the spring. But if we look in our question, the manufacturer is applying only two forces. One is 100 newton and another is 200 newton during the investigation. The investigator needs to increase the range of the forces to see the impact of forces on the extension of the spring. The investigator also needs to use the identical springs, not only one spring, during the investigation. More than one experiment must be done to see the values which are anomalous values in our experiment. Remove the anomalous values so that we can calculate the exact extension in the spring. Let's see the model answer. The investigator should use a greater range of the forces, means use more than two forces in the investigation because it will give more detailed behavior of the spring. Test more identical springs during the investigation, or the student can write the options such as repeat the experiment and remove the anomalous results and calculate the mean extension value. The other option which the student can write using wider range of forces to find the limit of proportionality of the spring or elastic deformation. Question number 2. A car contains a device called a black box. The black box records the distance traveled and the time taken for each journey. Figure number 3 shows the distance time graph for a part of a journey. In the graph, we can see here the time is along x-axis and the distance is along y-axis. The graph is given here. We can see the graph is going a straight line and it is curved and it becomes horizontal. If the graph is becoming horizontal, it means the distance is not covered anymore. So the journey is finished or the car has stopped. If the graph is getting curved, we can see here it means the deceleration is happening, the car is slowing down. And if the straight line is present here, it shows a steady speed of the car. 2.1 is an AO2 question, and this question is from the distance time relationship. What feature of figure 3 shows that car travels at a constant speed for first 4 seconds? If we go here up to the first 4 seconds, we can see here the graph is a straight line. For the steady speed, it is not necessary that the graph should pass through the origin. We have 3 different options. We need to pick one of the options. The lines become horizontal. We can see here if the line is becoming horizontal, it means the car has stopped. If we take that the line is passing through the region, a curved line can also be passing through the region, but it is not showing the steady speed or the constant speed. For the first 4 seconds, we can see here a straight line is present which shows a constant behavior of the graph. So the correct option is the line is straight. Two point two is an AO3 question, and this question is again from the topic of the distance time relationship. After 4 seconds, the driver applied the brakes and the car slowed down and stopped. The distance the car traveled after the brakes are applied is called the braking distance. Determine the braking distance of the car. Use the figure number 3. We need to use the figure number 3 after 4 seconds. From figure number 3, we can see here after 4 seconds, the graph is getting curved and it shows that the driver is applying the brake and it is slowing down. So we need to find the braking distance after 4 seconds. At 4 seconds, the value from the graph is about 64 meters, and up to that it gets stopped, that is about 84 meters. The distance traveled after 4 seconds when the driver is applying the brake, that is 84 meter minus 64 meter, that is about 20 meter. Let's see the model answer. Read the graph from 64 meter to 84 meter. The difference is 84 minus 64, that is 20 meters. After 84 meter, the graph is getting flat, which shows the car has stopped. Student will get 1 mark for reading the graph correctly and 1 mark for finding the distance. 2.3 is an AO2 question, and this question is from the topic of acceleration. As the car decelerates, means slowing down, the velocity of the car changes by 16 meters per second. The change in velocity is already given, that is 16 meters per second. A car decelerates for 2.5 seconds. So time is already given, that is 2.5 seconds. Calculate the deceleration of the car, use the equation. So deceleration is already given here, that is change in velocity over time. We have change in velocity, that is 16 meters per second, and time is already given here. We will use the equation to find the deceleration of the car. Let's see the model answer. The change in velocity is given, that is 16 meters per second, and time is also given, that is 2.5 seconds. We need to find the deceleration. We are going to use both the value in our equation. So deceleration is equal to 16 over 2.5. With the help of the calculator, we can find the value, that is 6.4 meter per second square. 2.4 is an AO1 question, and this question is from the topic of factors affecting the braking distance. If the black box records a large decelerations, it identifies that the driving may be dangerous. Why can large deceleration be dangerous? Large decelerations means that slowing down very quickly. So the driver is going to apply the sudden brakes, and the result of that, it becomes dangerous. When the decelerations are happening on the larger scale, it means the brakes of the car will get overheated and the driver may lose the control on controlling the car. So the correct options are the brakes of the car can overheat. On applying the sudden brakes, the driver may lose the control of the car. Large deceleration doesn't mean the force applied by the brakes is very small. Or the large deceleration doesn't mean the reaction time of the driver will increase. The large deceleration doesn't mean that thinking distance is very short. 2.5 is an AO1 question, and this question is from the topic of stopping distance. The black box monitors the speed of the car. Describe how the speed affects the braking distance. If the speed of the car is very high, then it needs the longer distance to get stopped. So the braking distance will increase. It means the car needs the longer distance to get stopped due to high kinetic energy value. The higher the speed, the longer the braking distance is required by the car to get stopped. And the reason behind it is that it has a high kinetic energy, therefore it needs longer distance to get stopped. Question number 3. Figure number 4 shows iron fillings sprinkled around a bar magnet. You can see here the iron fillings are present here, and this is a bar magnet. 3.1 is an AO1 question, and this question is from the topic of magnetic fields. Why are the iron fillings attracted to the bar magnet? You can see here the iron fillings are arranging themselves around the magnet. Tick one box. We have different options here. The iron is a metal, iron is charged, iron is heavy, or iron is magnetic. All metals are not attracted by the magnet. The reason why the iron fillings are arranging themselves around the magnet is that iron is a magnetic material. The reason is iron is metal and is also magnetic. Therefore, the iron fillings are arranging themselves around the magnet. All the metals are not magnetic. Therefore, they are not attracted by the magnet. The correct option is iron is magnetic. As a result of that, we can see here from the figure, the iron fillings are arranging themselves in a pattern around the magnet. 3.2 is an AO1 question. The figure number 5 shows a bar magnet, and this question is from the topic of magnetic field. Draw the magnetic field lines to show the magnetic field pattern around the bar magnet. You should add the arrows to the field line to show the direction of magnetic field. So we know that the bar magnet has two poles. One is called the north pole and another is south pole. The magnetic field lines always start from the north pole and they end at the south pole. Students need to use the arrows to show that from which direction the fields are starting and in which direction the fields are ending. So the magnetic field lines are starting from the North Pole and they end at the South Pole. (3.3) is an AO3 question. The figure number 6 shows two ball magnets. You can see here the ball magnet is showing X and Y. And this question is from the topic of poles of a magnet. The magnets attract each other, so this pole and this pole are attracting each other. What conclusion can be made about the two poles marked X and Y? We know that the opposite poles of the magnet they attract each other, whereas the like poles always repel each other. If these two poles are attracting each other, it means that they are opposite. So the correct option is they are opposite poles. Figure number 7 shows some plotting compasses around a wire. There is no current in the wire. 3.4 is an AO3 question. Why do the plotting compasses all point in the same direction? We can see here all of them are in the same direction. And important information is already given here. There is no current in the wire. The tip of the needle of the compass that is magnetic, and Earth itself has a magnetic field around it, like there is a big magnet in the Earth. Therefore, the needles of these compasses are aligning themselves according to the Earth's magnetic field. Let's see the model answer. The compass magnetic field lines up with the Earth magnetic field because the tip of the compass needle that is also made up of magnet and that is attracted towards the Earth magnetic field. Therefore, all the compasses which are shown in the figure they are aligning up with the Earth's magnetic field. 3.5 is an AO1 question. When the switch is closed, there is a current in the wire. The current creates a magnetic field. What shape are the magnetic field lines around the wire? And this question is from the topic of electromagnetism. If you look here, when the current starts flowing, the direction of the current is downward. With the help of the right hand rule, we know that the direction of the current is downward. The curling fingers are showing the circular shape of the magnetic field around the wire. Therefore, the shape of the magnetic field lines around the wire that is circular. A student investigated the force exerted by an electromagnet on a paperclip. We can see here when the current flows through this coil, it becomes magnet. Therefore, we call it electromagnet, and it applies the force on the paperclip downward because the paperclip is made up of iron, and if it apply the force and it will move downward here. The student varied the distance between the paperclip and the electromagnet. Figure number 8 shows the equipment used. We can see here when the current flows through the coil, it becomes magnet. As a result, it applies the force on the paperclip downward. The student recorded the reading on the Newton meter for several different distances. 3.6 is an AO3 question. The current in the electromagnet was same for each distance. Same means not changing. Complete the sentence. In the investigation, the current was dash variable. It is already mentioned the current in the electromagnet is not changed. It remains same for each distance. As the current is not changing, therefore it is a control variable. The correct option is that current was a control variable. Three point seven is an AO2 question. What is the size of the downward force on the paperclip in figure number 8? This question is an AO2 question and it is from the topic of electromagnetism. We need to find the value on the Newton meter from figure number 8. From figure number 8, we can see here the Newton meter is showing the value of 3.5 here, but we need to find the arrow. The arrow is present here about 3.6. So it is very clear from the figure number 8, the force on the Newton meter, that is 3.6 Newton. From the figure number 8, we can see here the downward force is 3.6 Newton. 3.8 is an AO1 question, and this question is again from the topic of electromagnetism. The distance between the paper clip and the electromagnet is increased. What happens to the size of the downward force? We need to use the figure number 8. From figure number 8, if this distance has increased, it means that the downward force has decreased. If the downward force is decreasing, there is less force of attraction on the paper clip. If there is less force on the paper clip, therefore the paper clip will start moving upward, and the distance between the paper clip and the electromagnet will increase. So the value of the downward force will decrease. As the result of that, the distance between the paper clip and the electromagnet will increase. Question number 4. Sound waves or longitudinal waves? 4.1 is an AO1 question, and this question is from the topic of transverse and longitudinal waves. Figure number 9 shows a sound wave which is given here. Complete the labels on the figure number 9. Choose the answer from the box. If you look in figure number 9, we can see here the particles are very close in this region, whereas in this region the particles are away from each other as compared to this region. A longitudinal wave consists of two main parts. One is where the particles are very close, that is called compression. So this is the compression region of the longitudinal wave, whereas the place where the wave particles are away from each other, that is called the rarefaction. The part of the wave where the particles are away from each other, that is called rarefaction. So this is rarefaction and this is compression. So the label parts are compression and rarefaction. So this is the compression region of the longitudinal wave, and this is the rarefaction part of the longitudinal wave. The student must know the properties of the longitudinal waves to answer the question 4.1. 4.2 is an AO1 question. It is from the topic of transverse and longitudinal waves. Which of the following is true for the longitudinal waves? Tick one box. Longitudinal waves transfer charge. Longitudinal waves are not carrying any charge. Therefore, this is a wrong option. Longitudinal waves transfer energy. All waves transfer energy from one place to another place. The last option is longitudinal waves transfer matter. Longitudinal waves are not transferring the matter from one place to another place. So the last one is also an incorrect option. The correct option is longitudinal waves transfer energy. Figure number 10 shows a device. The farmer is using to produce the loudest sound to scare the birds. The farmer measures the sound emitted by the device at distances from the device. So this device is producing the sound as sound is travel in the forward direction. 4.3 is an AO2 question, and this question is from the topic of properties of waves. Figure number 11 shows a visual display of the sound waves at different distances from the device. Both waves are drawn to the same scale. In figure number 11, we can see the wave pattern at a distance of 80 meters and at the distance of 200 meters. We can see the number of waves are 2. 1 and 2. Similarly, the number of waves on the second pattern are also 2. We can see here the size of one wave is same in both of the patterns. But if we look into the amplitude, we can see the amplitude at the distance of 80 meter is higher as compared to the distance of 200 meter. The amplitude is low as compared to the amplitude of the wave at 80 meter. The frequency of the wave both at 80 meters and 200 meters is same. Which property of the wave changes between 80 meter and 200 meter? Because the scale is same, the number of waves is same, the frequency is same, therefore we can see the amplitude of the waves is different in both of the waves pattern at the distance of 80 meter and at the distance of 200 meters. The amplitude is actually the distance from the mean position. We can see here the distance from the mean position here is higher as compared to this one. The main difference between these two waves pattern is that is amplitude of the waves. So the correct option is amplitude of the waves. Figure number 12 shows how the speed of the sound emitted by the device is affected by the temperature of the air. We can see here as the temperature is increasing, the speed of the wave is also increasing. The normal speed of the sound in the air is about 330 meters per second. As the temperature is increasing, the speed of the wave is increasing. 4.4 is an AO2 question, and this question is from the properties of the waves. The farmer tests the device on a day when the temperature of the air is 15 degrees Celsius. What is the speed of the sound emitted by the device when the temperature of the air is 15 degrees Celsius? The student need to use a ruler and to find the speed of the wave from the figure number 12. At temperature of 15 degree, we will draw the straight line up to the graph and we will move towards the left. And we can see here the speed of the sound at the temperature of the 15 degree Celsius is 340 meter per second. So the correct option is 340 meter per second. (4.5) is an AO2 question. The farmer stands a safe distance from the device. It takes a time of 0.2 seconds for the sound to travel from the device to the farmer. Calculate the distance traveled between the device and the farmer, where the equation is given distance is equal to speed into time. The time is already given, that is 0.2 seconds. The farmer needs to calculate the distance and the speed is already calculated, that is 340 meters per second. The farmer needs to find the distance, so both the values are used in this equation and we can find the distance is equal to speed into time. The speed is 340 and time is 0.2 seconds. Let's see the model answer. So distance is equal to speed into time. Speed is 340, which we calculated from the question number 4.4. And the time is already given, that is 0.2. With the help of the calculator, we can find that is 68 meters. So the distance calculated between the device and the farmer is 68 meters. 4.6 is an AO3 question. It is an investigation based question and student needs to give the reason, and this question is again from the topic of properties of wave. Explain how the time taken for the sound to reach the farmer is affected by the temperature of the air. Use figure number 12. In figure number 12, we can see here it is a straight line which is showing that as the temperature is increasing, there is an increase in the speed of the sound. From figure number 12, we can see here as the temperature of the air is increasing, the speed of the sound is also increasing. Therefore, the sound will take less time to reach the farmer from the device. Let's see the model answer. From figure number 12, as the temperature of the air increases, so the speed of the sound is also increasing. Therefore, the time taken for the sound is less to reach the farmer. Question number 5. Figure number 13 shows an engineer climbing up a ladder. The distance between each rung on the ladder is 30 centimeter, which is already mentioned. That is 30 centimeter. What is 30 centimeter in meters? It means we need to convert the centimeters into meter. We know that 1 meter is equal to 100 centimeter. Student need to calculate the answer from centimeter to meter. Therefore, it is an AO2 question. So 1 meter is equal to 100 centimeter. To convert centimeters into meters, we need to divide the values by 100. So 30 centimeter is the distance between the rungs. So we need to divide 30 centimeter by 100. So answer is 0.30 meters. So the correct answer is 0.30 meters. Five point two is an AO2 question, and this question is from the topic of work, power and energy. The engineer has a weight of 710 newtons. Calculate the work done when climbing up one rung of the ladder. Use the formula work done that is equal to force into distance. The weight of the engineer is acting as a force, and the unit is already mentioned, that is newtons. So the weight of the force is 710 newton. We know the distance traveled for one rung, that is 30 centimeter, and we need to convert 30 centimeters into meters by dividing it by 100. So the distance traveled by the engineer is 0.3 meter. The work done, that is equal to force into distance. We will use both the values in our formula and will get the work done by the engineer. Let's see the model answer. So the work done, that is equal to force, which is 710 newton, and the distance traveled, that is 0.30 meters. We will substitute both the values in our equation. So the answer is 213 newton meter. 5.3 is an AO3 question. The student need to give the reason for their answer. The engineer climbs the ladder carrying some equipment. Give the reason why carrying the equipment increases the work done by the engineer when climbing the ladder. We need to use the figure. Number 13, we can see here the engineer is climbing up. It is carrying different tools and equipment which increase the weight of the engineer. Therefore, the engineer needs to do more work to carry the tools and equipment while climbing up the ladder. Let's see the model answer. Carrying the equipment or the tools increases the weight, means the force, and we know that the force is acting downward. Therefore, the work done will increase. 5.4 is an AO2 question, and this question is again from the topic of work, power and energy. The engineer is stationary at the top of the ladder. Which energy stores of the engineer increases due to the engineer climbing the ladder? We can see here when the engineer is climbing, so it has gravitational potential energy due to the height from the ground. When the engineer is working, its chemical energy is decreasing and the thermal energy of the surrounding will increase. Therefore, when the engineer is working at the top of the ladder, it has gravitational potential energy due to the height and thermal energy due to working at the top of the ladder. 5.5 is an AO1 question, is a knowledge-based question, and this question is from the topic of gravity. Write down the equation that links gravitational field strength G, mass, m and the weight. We know the formula for the weight is W is equal to mass into gravitational field strength, or W is equal to m into G. 5.6 is an AO2 question. The engineer has a weight of 710 Newton. So we have weight. The gravitational field strength value is 9.8 Newton per kilogram. Calculate the mass of the engineer. So we know that weight is equal to mass into gravitational field strength. The weight is already given, that is equal to 710 newtons. Gravitational field strength is 9.8 Newton per kilogram. We need to find the mass of the engineer. We know that weight is equal to mass into gravity, and we can use the question 5.5 to answer our question. So in a triangle formula, we need to find the mass. So mass is equal to weight divided by gravitational field strength. Let's see the model answer. Weight is equal to m into g. The weight of the engineer is 710 newtons. Mass we need to find, and value of g is 9.8. 9.8 will go on the other side of the equation and it will divide 710 and we will make mass as a subject. So the answer is 72.448 kilograms. The demand of the question is up to two significant figures. The two significant figures are 72. And if we round the data, the answer is that is 72 kilograms. So the mass of the engineer is 72 kilograms. Question number 6. The sun emits a continuous spectrum of electromagnetic waves, means EM waves. Figure number 14 names some of the groups of the waves in the electromagnetic spectrum. We can see here we have infrared radiation, visible light, ultraviolet radiations, and gamma rays. (6.1) is an AO1 question. Name the group A, B, and C in figure number 14. We know that in electromagnetic spectrum, we have the radio waves, microwaves, infrared radiation, ultraviolet radiation, we have gamma radiation, we have X-rays, and we have visible light. Out of the 7 of electromagnetic radiations, we have only 4. Infrared, visible light, ultraviolet, and gamma rays. The electromagnetic spectrum, it starts from radio waves and ends at gamma rays. So the A is radio waves, B is microwaves, C is X-rays. Let's see the model answer. So A is radio waves. In our spectrum, B is microwaves and C is X-rays. It is an AO1 question. The student must know the names of the waves in the electromagnetic spectrum. 6.2 is an AO1 question, and this question is again from the topic of electromagnetic waves. Give one similarity and one difference between the properties of ultraviolet waves and gamma rays. If we look into ultraviolet waves and gamma rays, we can see both the rays are from the EM spectrum. As both of them are from the EM spectrum, so they have same speed. Both can travel through the vacuum and both can transfer the energy from one place to another place. And both of the waves in the electromagnetic spectrum are transverse waves. But on the other hand, the ultraviolet radiation is less ionizing as compared to gamma rays. We can see here the frequency of the wave of the ultraviolet radiation is less as compared to gamma rays. Gamma rays are more penetrating due to having high energy as compared to ultraviolet radiations. Let's see the model answer. The different options are given in similarities and differences for the students. The similarity between ultraviolet waves and gamma rays is both have the same speed, that is 3 into 10 raised to power 8 meter per second. Both can travel through the vacuum and both are transverse waves. The student can pick one of the difference. Gamma rays have high frequency than ultraviolet waves. Gamma rays are more ionizing than ultraviolet waves. Gamma rays are more penetrating than ultraviolet waves because of having high energy. Gamma rays have shorter wavelength than the ultraviolet waves. You can see here the size of the wave is shorter as compared to the size of the wave in ultraviolet radiation. Figure number 15 shows a white light splits into the spectrum of different colors by a glass prism. You can see here a white light is entering into the prism and it splits up into different colors. 6.3 is an AO1 question, and this question is from the properties of EM waves. Light changes direction when it enters the glass prism. What name is given to this process? We know that as the light is entering from one medium to another medium, it changes the direction. And the change of direction is called refraction. A student must know the definition of refraction so that they are able to give the answer of 6.3. It enters from the air into the glass prism or from one medium to another medium. Therefore, the ray of light is changing the direction and splits up into different colors. So the name of the process is refraction. Student can use the equation sheet to answer 6.4 and 6.5. 6.4 is an A1 question, and this question is from the topic of properties of waves. Write down the equation that links frequency, wavelength, and the wave speed. From the equation sheet, we can see that the speed of the wave is equal to frequency times wavelength. So V is equal to F into lambda. 6.5 is an AO2 question. The student need to make the calculation in this question. The wave in the middle of the spectrum has a wavelength of 5 times 10 to the power minus 7 meter. The wavelength is given. The wave speed of the light, that is 3 into 10 to the power 8 meter per second. Calculate the frequency of the wave. In 6.5, we know that V is equal to F times lambda. The wavelength is given, the speed is given, we need to find the frequency. We will use both the values in the above equation and we can find the frequency of the wave. Let's see the model answer. From 6.4, we know that V is equal to F times lambda. Wavelength and speed are already given. So we will use these values in our equation. So the speed is 3 10 to the power 8 meter per second, and the frequency we need to find, whereas the wavelength is given 5 times 10 to the power minus 7 meter. By rearranging the equation, the frequency is 6 into 10 to the power 14 Hertz. Frequency of the wave 6 into 10 to the power 14 Hertz. The marks distribution is given along each required step. Question number 7. A student investigated how the acceleration of a trolley is affected by the force acting on the trolley. Figure number 16 shows some of the equipment used in the experiment or in the investigation. If we look into the question 7.1, describe a method the student could use. Your answer should include any extra equipment needed. This question is from the topic of Newton's second law, and it is an AO3 question. We need to use the figure and we'll see that what the extra equipment a student needs to use in the investigation. We can see there the trolley is at the ramp, and the student will use the string and tie the string to the trolley and pass the string over the pulley at the edge of the desk or the table. On the other side of the string, the student will hang the weight holder and adds the weight and see that impact of the force acting on the trolley. The student can put the start mark of the trolley so that he can find the distance between 2 points to find the acceleration of the trolley. Or the student can use the light gates to find the acceleration of the trolley, and with the help of the computer or the data logger, the student can find the acceleration of the trolley. The student can add the weight and see the impact of the force on the trolley. As the weight is increasing, it means the downward force is increasing. It will apply more force on the trolley. As a result of that, the acceleration of the trolley will increase. Let's see the model answer. Number 1. Clamp a pulley onto the edge of the desk as shown in the figure number 16. Use the light gates to find the acceleration of the trolley with the help of the data logger. Or the student can use the stopwatch to find the distance traveled and use the formula V is equal to S over T and acceleration is equal to delta V over T to find the acceleration of the trolley. Attach a string with the trolley and passing over the pulley and is connected with the mass or the weight holder to see the effect of the force on the acceleration of the trolley. Mark the starting point of the trolley on the runway to measure the distance traveled by the pulley during the experiment. Add mass to the weight holder and find the force W is equal to mg on the trolley to move it on the runway. The student will repeat the experiment for different masses of the forces and observe the effect of the acceleration due to the change of masses. Table number 2 shows some relation between the force and the acceleration. The force is 1.2 Newton, the acceleration is 1.6 meter per second square. 7.2 is an AO1 question, and this question is from the topic of Newton's second law. Which of Newton's law predict that the acceleration of the trolley is proportional to the resultant force? We know that Newton's second law says the force is directly proportional to the acceleration. As the force is increasing, the acceleration produced in the trolley will increase. So it is Newton's second law which relates the force and the acceleration. Seven point three is an AO3 question, and this question is from the Newton's second law of motion. Determine the acceleration of the trolley when the resultant force is 3.6 Newton. Use the table number 6. We will explain this question by two different methods. We need to use the table number 2 and we need to calculate the acceleration produced due to the force of 3.6 Newton. In table number 2, we can see here if the force is 1.2 Newton, the acceleration produced is 1.6 meter per second square. But we don't know what is the acceleration when the force is 3.6 Newton. There are two methods. When the force is 1.2 newtons, the acceleration produced is 1.6 meter per second square. And when the force is 3.6 Newton, we don't know the acceleration. So we are using ratio and proportion method to find the acceleration. To make x and a subject by ratio and proportion method, the x is equal to 1.6 times 3.6 and 1.2 will divide it. The answer is 4.8 meter per second square. We will use table number 2 for our second method. We know that in table number 2, the force is 1.2 and acceleration is 1.6. We will use Newton's second law, F is equal to ma, to find the mass of the trolley. The mass of the trolley is F over a. We will divide the force by the acceleration to find the mass of the trolley. The mass of the trolley is 0.75 kilogram. We know that the force is 3.6 Newton and the mass is 0.75 kilogram. We will use the formula F is equal to ma to find the acceleration produced by a force of 3.6 Newton. Let's see the model answer. We already calculated our mass, that is 0.75 kilogram of the trolley. We will use the formula F is equal to ma. The force is 3.6 Newton. The mass is 0.75 kilograms. We need to find the acceleration a. We will make a as a subject. Therefore, 0.75 will divide 3.6. With the help of the calculator, The answer is 4.8 meter per second square. Student can use any of the method, whether by ratio proportion method or by calculating the mass first and using the Newton's second law. 7.4 is an AO1 question. The student can use the equation sheet to answer 7.4. Write down the equation that links acceleration, mass, and the resultant force. So we know that the force is equal to mass into acceleration of the object, which is actually the Newton's second law. So the resultant force is mass into acceleration. 7.5 is an AO2 question, and this question is from the topic of Newton's second law. The force is given 0.42 Newton and the acceleration is 1.2 meter per second square. The student need to calculate the mass. We will use the equation force is equal to mass into acceleration. The force is already given. Acceleration is 1.2 meter per second square, and we need to find the mass of the trolley. Let's see the model answer. We know that force is equal to mass into acceleration. The force is 0.42 Newton. The mass we need to find, and acceleration is 1.2 meter per second square. To make mass of the trolley as a subject, 1.2 will go on the other side and it will divide 0.42. So the mass of the object is, or the mass of the trolley is, by using the calculator, that is 0.35 kilograms.